Hello, grade 12s. Welcome back once again to this channel, and today we're gonna be focusing on digits, codes, and passwords. It's still part of fundamental counting principle, and I think it's actually the last part of counting principle. Then the upcoming videos are just be showing you how to solve different problems in counting principle. Okay, so today you will learn about how to calculate the total number of different codes, pins, and also password that can be arranged or created, that can be formed using counting principle. So we want to know, we have digits, right? So digits are from 0 to 9. So using those digits, we can form different codes, we can form many pins, we can form many passwords, and most company just use this system of counting principle actually to determine how many different pins can they create if maybe they want to create certain codes for certain privacy and security, and they might just want to know how many different pins can they create in order to actually predict whether it will be possible for one to guess that pin or to guess that code. So you can see that counting principle, it's not only useful in terms of theory, but also in practical or real world. So without the waste of time, let's quickly look at this example. They say a security system requires a user to choose a security code, and the code consists of 4 digits. This is a very important statement. The code consists of 4 digits, right? So it must have 4 spaces. So it must be 1, 2, 3, 4, because it's 4 digits. There must be 4 positions for those digits. So how many different codes? I was supposed to write how many different codes can be chosen if the system allows a repetition of digits. If the system allows repetition of digits. Now, they tell you that the security system is required to choose a security code, right? So that code consists of 4 digits. We have already indicated 4 spaces there. But how many different codes can be chosen from if the system allows a repetition of those digits? Okay, now in counting principle, remember, don't forget, we think about the number of choices or options that we have in a particular case. So in this case, it's about digits. So you must think, how many digits do you have to choose from? It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digits that you can choose from. It's 1 to 9, which is 9 digits, and including 0, making it 10 choices, 10 digits that we can choose from. So if the system allows a repetition of digits, what does it mean? Okay, in the first option, how many choices do you have? You can either choose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 10 choices in the first position, right? Let's move to the second position. The system allows a repetition of digits. It means the digits that we would have selected in this space, we can also select it again in this space. So in total, we still have how many choices? 10 choices. So they don't decrease as in like in other examples that we've been doing. So because a repetition is allowed, the repetition of digits is allowed. It means the same digit you used previously, you can use it again. So your choices still remain 10s throughout these positions. So in total, it will be 10 exponent 4, which will give you 10,000 codes. So in total, they can actually produce 10,000 codes if repetition of digits is allowed. So let's move to number 2. The system does not allow repetition of digits. Okay, so remember they want to produce the code consists of 4 digits, so we must have 4 spaces, 1, 2, 3, 4. But then the system does not allow repetition of digits. Remember, we are choosing from digits 0 to 9. These are our digits. So in the first position, if the system, actually, let's start with this. In the first position, how many choices do we have? That's the question you asked yourself while answering counting principle question. So you can either choose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 10 choices in the first position. But in this space, you are going to choose one digit. It means because the repetition is not allowed, we can cancel one of the digits from the 10 choices. How many choices will you be left with? 9 choices. Remember, repetition is not allowed. Now you have filled 2 spaces with digits. It means from your choice of 10 digits, 2 are gone. Remember, repetition is not allowed. 2 are gone. How many are you left with? 8. Then how many are you left with? 7. Then we just use a calculator to get the number of codes that they can form if repetition is not allowed. It says 10 times 9 times 8 times 7. This will be 5,040 codes that they can form. 5,040 codes. I hope that was understandable. Let's move to other examples. How many 3-digit numbers can be made with the digits 1 to 5? Now we are not choosing from all digits. They actually say with the digits 1 to 5. So it's 1, 2, 3, 4, 5. How many 3-digit numbers? So it must be 3-digit numbers. 3-digit numbers. So we create those 3 spaces there. Can be formed if repetition are allowed. Okay. In the first position, how many choices do we have? We can choose 1, 2, 3, 4, or 5. So we have 5 choices. So this position is going to be filled with a digit, right? But because repetition is allowed, our choices still remain 5. We can either choose any of them because we can repeat. So because repetition is allowed to remain 5. So this will be 5 exponent 3, which will give you 125. 125 numbers that can be formed. There are 125 digits numbers that they can form if they repeat. The repetition of digits is allowed. Let's move to B. If repetitions are not allowed, we want to form 3-digit code. In the first position, you can either choose 1, 2, 3, 4, 5. You have 5 choices. But then in the second position, the first position has been filled with a digit. It means we'll cancel one of them. How many choices do you have in the second position? It will be 4. How many choices? You have used 2 of the digits. From 5 of them, how many choices do you have? 3. Why? Because repetition is not allowed. So it's 5 times 4 times 3. This will give us 60 digits numbers that can be formed. 60 digits numbers that they can form. Okay, let's move to this other example. They are saying a code is made using the format X, Y, Y, where X is any letter. This is an important statement, where X is any letter in the alphabet. Remember, counting principle deals with the number of choices that we have in a particular situation. So you must know how many letters are there in the alphabet. You must know how many letters are there in the alphabet. And Y represent any digit from 0 to 9. Okay. Let's start with A. How many possible codes can be formed if the letters and digits are repeated? How many codes can be formed if the letters and digits are repeated. Okay, our code is in the format of X, Y, Y. So it's only 3 position, X, Y, Y. X is representing any letter in the alphabet. The question we ask ourselves, how many choices do we have for letters in the alphabet? How many letters of the alphabet are there? We have 26 of them. So because in the first position, we write 26 because that is the number of choices we have in that particular position. Let's move to the second one. The second, the last 2 positions are represented by YY, right? And Y represent any digit from 0 to 9. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In total, how many choices do we have? 10 digits to choose from. So it's 10. So because digits and letters can be repeated and YY represent digits, it means even in the second and the last position, we'll have to choose from 10 choices because we can repeat them. So we just multiply out all those number of options, then we get the possible codes that can be formed. So in total, it will be 2,600 possible codes that we can form if we are repeating the letters and the digits. B, how many possible codes can be formed if the letters and digits are not repeated? How many possible codes can be formed if the letters and digits are not repeated? Okay, remember we are in the format of X, Y, Y. How many choices of letter? X represent the letter in the alphabet. How many of them? There are 26, right? Great. So let's move to this other position. Y represent the digit from 0 to 9. So in this position, how many choices of digits do you have? You can choose 0, 1, 2, 3, 4, 5, 6, till 9. So you have 10 choices. Let's move to the last position. No repetition. They are not repeated. It means because we'll have to choose from 10, one is used, it means one of them will go out from that options. So we'll be left to choose from 9 of them. Then we just multiply out those number of choices we have. Then we get the number of codes that they can form if that restriction is applied. So it's 2,340 codes that can be formed. I hope this is understandable. Let us move to our last example that was adapted from Kevin Smith textbook. I'll just put the link in the description and you can just order the book online. Okay. It says Jimmy has to create a 6-digit password for his email account. You see, counting principle is very useful in real life. So the password must start with 3 letters and end with 3 numbers. The person wants to create a password for his email account. So this is the restriction. The password must start with 3 letters and end in 3 numbers. How many different passwords can be formed for each of the following cases? A, repetition is allowed. We must have 1, 2, 3 letters, 1, 2, 3 numbers. If repetition is allowed, how many codes, password can he form? For A. Okay, it's A, right? Okay. How many, remember, these are representing the letters. These are representing the digits. Now repetition is allowed. In the first position, how many letters will they have to choose from? A to Z. He has 26 choices. Because repetition is allowed, they still have 26 options here. Repetition is allowed, he still have 26 options there. Let's go to digits. We have digits from 0 to 9. How many total digits do we have? We have 10 digits. So it will be 10 choices of digits. Because the repetition is allowed, it will still remain 10. So the total number of passwords that it can form, we just multiply those outcomes there. Then it will give us the total number of codes that the person can form. So it's 26 exponent 3 times 10 exponent 3. Whew, it's a lot. It's around 17 million. So it's really a lot. So it's 17,576,000 passwords that can be formed. Let's move to B. If repetition is not allowed, we must have 3 letters and 3 codes. Digits. Okay. Repetition is not allowed. In the first position, you will have to choose from letter A to Z. You have 26 choices. Because the repetition is allowed, in this position, only one letter is going to sit. It means when we come to this position, we will have to choose from 25 of them because you cannot use that again. Repetition is not allowed. Then here, you will have to choose from 24. Let's go to digits. In the first position, you can choose from 0 to 9. He has 10 choices of digits. But because he's going to place 1 here, it means the digit that will be left, he will be left only with 9 options. Then after those 2 digits have placed, we will subtract 2 from the total. He will be left with 8 choices. So in total, we just multiply out those outcomes. Let's see, so it's 26 times 25 times 24 times 10 times 9 times 8. It will give us 11,232,000 passwords that can be formed. Quite a lot. It's actually a lot. It's a lot. Okay, let's move to C. This is another restriction. The vowels may not be used and repetition is not allowed. The vowels may not be used and repetition is not allowed. Okay, remember the first 3 form letters, the last 3 form the digits. Repetition is not allowed, vowels may not be used. So this, when they say vowels may not be used, they are restricting in terms of letters, right? So what are the vowels in our letters? Our vowels is A, E, O, U. So when I was still in grade R, that's how they taught us, A, E, O, U. That's our vowels. So how many vowels do we have? 1, 2, 3, 4, 5. We have 5 vowels. So because they are saying vowels may not be used, we are going to subtract all vowels from the total number of letters. In total, we have 26 letters. But because vowels may not be used, we have to remove 5 of them, 5 letters from those one, minus 5 letters. Then we'll be left with the ones that don't have the vowels. So we'll be left with 21 letters, right? So it means when the vowels are not included, our first choice is 21. Remember, repetition is not allowed. It means because here we have choose from 21, when we come to this position, when we come to this position, one of them has been used, we'll be left with how many choices? 20 choices. 2 of the letters has been used, we subtract them from 21, we'll be left with 19 choices. Okay, the last one from the digits. The digits we have from 0 to 9, we have 10 choices, but a repetition is not allowed. It means here we'll be left with 9, here 8. You just multiply out those number of outcome, then you get the answer. So it's 21 times 20 times 19 times 10 times 9 times 8. It's giving me, I think it's 5 million. No. Yeah, I think it's 5 million. Let me just write down this thing. 574545 yeah, it's 5.7 million something passwords that can be formed. All right, I hope that made sense. Let's move to D. The number formed may not start with 0 or an even number, and repetition is not allowed. Now they are restricting on the side of digits. So with the letters, we still have the same style. I mean, the same choice from our letters. Okay, with the letters, let's start with the letters because they didn't say anything about letters. What they only said is that repetition is not allowed. So in the first choice, you still have 26 choice, but because repetition is not allowed, we'll have to choose from 25 of them. Repetition is not allowed, 24. Now let's go to digits. They're saying the number formed might not start with 0 or an even number, and repetition is not allowed. Okay, it's quite tricky, but you'll see. It's simple, by the way. The number formed might not start with 0. Okay, we have digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number formed might not start with 0. 0 is out in the first position, and might not end an even number. So it must not start with 0 or an even number. 2, 4, 6, 8 out. So how many choices do we have? It's 1, 2, 3, 4, 5 choices in the first position. So you have 5 choices. Okay. Repetition is not allowed. So the mistake that many students can make, because they know repetition is not allowed, it means it will be 4, it will be 3. No, it's incorrect in this place. Why? They're saying it must not start with 0 or an even number. Here we have 5 choices. It means here it can be 0 or an even number. So we include them again, but then without repeating. Okay, in this position, only one digit will sit. So from the total of our 10 digits, how many digits are we left to choose from? If we're subtracting one digit that has been used here, how many choices do we have now? If repetition is not allowed, we'll have 9 choices. Because repetition is not allowed, okay, I'll just write this later. Here we'll have how many choices? 8 choices. So don't make that mistake to say, okay, because repetition is not allowed, you just come and say, oh, it will be 4, it will be 3. No. The question only restricted us here in the first position. We have 5 choices, right? Because they say it must not start with 0 or an even number. But as we move, it can start with 0 or an even number. But then because the repetition is not allowed, we go from the total of 10, we remove the digit that is going to sit here. It is 1 digit. Then you'll be left with 9 choices. Then repetition is not allowed. You'll be left with how many? 8 choices. So don't forget that. So to get the answer, we just multiply out all this number of choices, then we can get the answer. So it's 26 times 25 times 24 times 5 times 9 times 8. So it's giving me 5616000 passwords that can be formed if this restriction is made. Oh, let me just write this answer properly. It's 5616000 passwords that can be formed. It's a lot because it's around 5 million, so it's too much. E. Let's come to E. If the first letter has to be a vowel and repetition is not allowed. 1, 2, 3 are letters, 1, 2, 3 are digits. The first letter has to be a vowel. I already showed you the vowels here. These are the vowels. How many choices do I have? That's the question you must ask yourself when answering counting principle questions. How many choices do I have? If they're saying the first letter must be a vowel. I only have 5 choices of vowels. So in the first position, it will be 5. Don't make that mistake that I highlighted in D. The first one, they only restricted you here. The first one must not be a vowel. It means here we can use a vowel. But in this position, one vowel is going to be used, right? So from the total of 26 letters, we subtract one vowel that has been used there. You are left with how many choices in this position? 25, because we cannot repeat. So don't forget that. We have 25 choices. Then when we move here, repetition is not allowed. We'll have 24 choices. All right. So with the digits, they didn't tell you anything. They just say repetition is not allowed. So we have a total of 10 digits to choose from. Because repetition is not allowed, we'll be left with 9, 8. So we just multiply out all those things and we can get the answer. So it is giving me 21, 6, 1, 2, 3, 4, like this. Passwords that can be formed. Whew. It's a lot of passwords, huh? How many of them? Because I have to look at this thing very carefully. I think it's around 2 million. Yeah, around 2 million something, 2.1 million. Okay, let's lastly look at F. I think we took a lot of time today. F, the number may not contain 5 and the repetition is not allowed. Remember, the first 3 form letters, the last 3 form digits. So they only restricted you in terms of the digits. That's right. So with the letters, they just say repetition is not allowed. So in the first position, you have 26 choices. Second position, because the repetition is not allowed, here we're going to place 1. It means we'll be left with 25 choices. 2 of them has been used. We'll be left with 24 choices. The number may not contain 5. If the number is not containing 5, right? We have how many digits? 0 to 9. We have a total of 10 digits. We have a total of 10 digits. If the number is not containing 5, it means we subtract 1 digit. We'll be left with how many choices? 9 digits to choose from, because we are removing 5. So the total digits we are left with is 9. So in this position, we'll have 9 choices. Repetition is not allowed. We already used 1 of them. We'll be left with 8 choices. We already used 2 of them. We'll be left with 7 choices. Then we just multiply out all those things. Then we get the answer to be 26 times 25 times 24 times 9 times 8 times 7. It's giving me 7862400 passwords that can be formed. So it's around 7 million. Thank you very much for joining us today. I think let's end here today. I've put down the link of other videos, Counting Principle Part 1 till Part 4, if not Part 5. I think this is Part 6, where we were talking about digits. Thank you very much. Enjoy the rest of your day. Thank you.